Hello, everybody. Welcome back to another episode of the Numerical Wizard. And as we move forward today, we are going to look at an interesting question, right? Which is still based off of trigonometry, right? So, with this question, right, let's try and see what can we do on said question, right? It says, right, we basically have a question where it says if they said, what did they say? They said if sine 38 degrees, right, is equals to what? To p, right? Determine the value of the following without using a what? A calculator, right? Before anything else happens, before you do anything else, right? You first, right? I'm sure now it's 5.1, right? So since it's 5.1, right? Hey, this one is ugly, but yeah, 5.1, right? The first thing you do is you draw your triangle, right? Your triangle should be drawn in this manner, right? It's on the first quadrant, right? Why is it on the first quadrant? Because they didn't say anything else, right? In terms of, is it, they didn't give us basically a restriction. That's what I'm basically trying to explain to you, right? So since they didn't give you a restriction of saying it must be between 90 and 360, you just draw your Cartesian plane exactly as it is, right? And then your triangle should be drawn what? On always on the first quadrant. If they don't say anything, you draw it on your first quadrant, right? So it says sine 38 is equals to p, right? So we know that p is the same as p over what? 1, because anything divided by 1 is exactly that specific number or variable, right? So it's sine 38, right? So let's write sine 38. It's sine 38 degrees, right? Sorry, it's just that doesn't it's not visible. 38 degrees, right? And then they said it's p over 1, right? So p, we know it is p over 1, or sine, we know it's opposite over what? Hypotenuse, right? So that means the angle which is being asked is our opposite, right? So that means this is our opposite, right? And our hypotenuse is always the longest side, right? Or your r when you're using your theorem of Pythagoras, right? So it's opposite, which is p. Your hypotenuse is 1, right? What's left is for you to always find the missing side, right? So that means it doesn't matter what they ask, whatever happens, you will always be asked to find the missing side. And you use that, you find that by using the theorem of Pythagoras, which is basically r squared, which is equals to x squared plus what? Y squared. Don't forget to write your reason, theorem of Pythagoras, right? Or you can just write Pyth, right? Full stop. You'll get your full marks, right? So your r squared, I said it's your longest side. So you just insert 1 squared, right? Your x squared is this side because this is the x-axis. So it should be x squared. This is the one we want, right? So since it's the one we want, we write it exactly as it is, right? X squared, right? Plus our y squared is p. So it's p squared, right? Now we want x squared, right? So we transpose p squared on the other side. So we will be having what? X squared, which is equals to what? 1 squared is the same as 1, so you can write 1 minus p squared, right? We want x, right? Not x squared. So we introduce a square root on both sides. What you do on the left side, you do on the right side, right? So we'll be left with what? Square root of what? 1 minus p squared, right? We have this. This is our final product, right? This is our final product. So that means our x here is what? Root of 1 minus p squared, right? That's our end product. So that means we don't need all of this, right? We are done with this. We were just filling in our triangle, right? So that when we answer questions, it might be easier for us. And the one last thing that you should do, right? Since you see there's 38 here, and this we know it represents a 90 degree. What's left there? What's the angle there at which is missing? What you basically do, you just say 90 degrees minus 38, right? So 90 degrees minus 38 is how much? Is 52, right? So there you write what? 52 degrees, right? 52 degrees, right? We're done with that. Now we start answering our questions, right? 5.1.1, it said calculate cos 218 without the use of a calculator, right? So what can we do in this instance, right? We check. In my last video, as I was explaining, we strive our best to reduce this big angle into a smaller angle in terms of what we've been asked, right? So we have 38 there and we have 218 here. I think we can use 180, right? 180 plus 38 is how much? Is 218. So we're representing 218 in a different format, right? 180 plus what? 38 degrees, right? And we know that 180 plus is on the third quadrant, and cos on the third quadrant is negative. So we must get what? Negative cos what? 38 degrees, right? And then at the end, right? Since we want cos 38 is basically adjacent, right? Adjacent over hypotenuse, right? So if it's adjacent over hypotenuse, is basically what? Is basically negative. And usually we have a negative, open brackets, root of 1 minus p squared, right? P squared. Sorry, I forgot to write a p squared there, right? All over 1, right? Because it's adjacent over hypotenuse, right? And then your end product is what? Negative root 1 minus p squared all over 1. Or you can just write negative root p squared, right? Because anything divided by 1, as I said, is that number or that variable, right? So this is how you conquer 5.1.2, your 5.1.1, right? And now we're moving forward to 5.1.2, right? So in 5.1.2, it's a bit interesting, right? Because it's showing a smaller angle. And what I was teaching is that we strive to reduce a bigger angle into a smaller angle, right? But now we already have a smaller angle. You're probably asking yourself, what do I do in this situation, right? In this situation, let's check. 5.1.2, it says cos 14 degrees, right? So we are trying to find cos 14 degrees, right? What we are striving to do is that initially we've been given 38 degrees. We can use 38 or we can use 52, right? Whichever one of those angles, we are supposed to use them at some point to get what we want, right? So cos 14, right? If you check something here, if you check when you subtract 52 and 38, right, you get 14. So that means 52 degrees minus 38 degrees, right, is the same as cos 14 because they give you 14, right? That's what we know, right? And then now, if you check clearly now, right, this is a compound angle of a cos, right? So how do we represent this with a minus in between? We say cos 52 degrees times cos 38, right? 38 degrees. 38 degrees plus sine 52 degrees times sine 38 degrees, right? So this is basically what we do all the time, right? So from this instance, now you can see that that 52 now plays a huge role in us finding what we want, right? So let's check. Cos 52 is this one, right? So when we have 52, our opposite for 52 is this, right? And our adjacent is p, right? So cos is adjacent of hypotenuse, so it's adjacent, which is p of hypotenuse, so which is basically what, p over 1, right, multiplied by what, cos 38, because 38 is adjacent of hypotenuse. 38, its opposite is p now. Its adjacent is root 1 minus p squared. So you write root 1 minus p squared all over 1, right? Plus sine 52. Sine 52 is opposite of hypotenuse, right? So it's what? Square root of 1 minus p squared, right? All over 1. Multiplied by sine 38. Sine 38 is opposite over hypotenuse, right? Which is p over 1, right? In this instance now, we can see that we can work on our equation better, right? So let me just remove this here and continue. P times square root of 1 minus p squared is basically just what? P root 1 minus p squared, right? Plus, right? Same here. P times this is just going to give us p root of 1 minus p squared, right? And then these are the same. This is the same as that. So it's basically x plus x, right? When we have x plus x, we have what? 2x. With that very same principle, right? We now say that 2p 1 minus p squared, right? Sorry, it's a square root there, right? So there's a square root there. So we basically just write this, right? And then we are done. We got our cos 14. So that means cos 14 degrees is equals to this, right? So we are done with 5.1.2. Now let's move on to 5.1.3, right? Also, this one is a bit tricky, but with the right conceptual understanding, you'll find a way. And then I'm here for you. I'll show you how you do it and how you impact, or how do you answer specific questions. And then yeah, let's check it out. So what do we have here, right? We have in 5.1.3, right? They said we have sine 26 degrees, right? Multiplied by what? Cos 26 degrees, right? So we want to solve for this. If you check, we have sine 26 degrees and cos 26 degrees. This almost looks like a double angle of a sine. What's missing is the 2, right? For it to be a double angle of a sine, right? So how do we get that 2, right? Here we know that there's an invisible 1, right? 1 times this is still the same, so nothing has changed. But we know that 1 over 2 multiplied by 2 is the same as 1. 1 over 2 times 2 is 1, right? So we can write sine 26 degrees times cos 26 degrees, right? And then now this whole part is a double angle of a sine, right? This whole part. So we can just reduce this, right? And say what? Sine 2 times 26, right? 2 times 26 degrees, right? Which is basically what? 1 over 2, 1 over 2, 1 over 2 sine 2 times 26 is how much? 52 degrees. Now we've gone back to our 52 degree, right? And sine 52, sine is opposite of hypotenuse. So basically our final answer should be what? 1 over 2 times what? Opposite of hypotenuse is root of 1 minus p squared, right? All over 1, right? And our ending should be root 1 minus p squared all over 2. That's your ending. That's your final answer. And yeah, thank you so much for being with me on this part, and see you next time on the next video.